Okay, this is not the way I would have approached it, but it's another valid way to approach it, and it's perfectly good. It's a good idea. Okay? We just write 2 to the kx is 2 to the k raised to the x, and that equals 3 to the x, right? Well, if something to the x equals something else to the x, then the something had better equal to something else, right? I mean, can't you pretty clearly conclude that 2 to the k has to equal 3? Okay? Now, just to be sure that's really so, we can say, okay, 2 to the k to the x raised to the 1 over x equals 3 to the x raised to the 1 over x. So 2 to the k has to equal 3. So we can use the laws of exponents to prove that it's valid to do this, but it's pretty obvious if any time you raise this to the x, you get the same thing you do when you raise this to the x, that this has to equal this, right? So you'd kind of almost be safe jumping from here to here, but it's better to do the algebra and just apply a law of exponents that makes it so. You might not see that step, so you'd be on a little bit shaky ground if you did this, but you'd end up being right, and I'd probably allow it, okay? Although you might have a little trouble writing the justification. Well, it's obvious if you raise this to any power, and it equals this to any power, and that happens for any power, then it's got to be so that this equals this, okay? Yeah, hopefully you'd be a little more articulate than that, but you know, you'd work on it. Okay, now, how do you solve this for k?
Times 3 over 1 over k? No, times both sides over 1 over k.
No.
Log.
Yeah. Okay. I knew if I shot that down, you'd come up with something. Okay. You change this to logarithmic form. What you're trying to solve for is in the exponent. Okay? Now, when I give you an assignment where you know that you're going to have to apply that, you do it just fine, right? I mean, most of you have done those assignments, you know, they've given in the last couple of weeks and well before that also. And you do it when you're expecting it, but when it pops up at you from here, you're not expecting it, and you think of something else. Well, you just got to learn to identify things like, okay, this is a quadratic equation. Okay, this equation has denominators. I'd better multiply both sides by each denominator, right? Okay? Oh, this is a linear equation. Oh, that's easy. Okay? But maybe only after you've multiplied by the common denominator. And well, you recognize it, okay? And if the thing you're trying to solve for is part of the exponent, you're going to have to change to logarithmic form. Now, if the thing you're trying to solve for is all of over here and not an exponent, well, you're out of luck. Okay? There's equations that can't be solved, and that's one of them. But an equation like this, you certainly can. So you see that k has to be log of base 2 of 3. Of course, that rule has to be second nature to you by now. We've been using it for over a month. Okay? Okay, well, what's log base 2 of 3? Well, let's see. 2 to the 1.6. Might be, it's between, I think, 1.5 and 1.6. I'm going to just take it, maybe it's about 1.6. Okay? You can take your calculator, do log 3 over log 2, which you also know how to do, right? Maybe you haven't done it in a couple of weeks and you've forgotten. So again, you want to kind of review that. Okay, so k is about 1.6. Okay, you can take your calculator and see how close I am. I'm not all that close. I'm thinking it's between 1.5 and 1.6. I'm not sure whether it's closer to 1.5 or 1.6. Visualizing the curve. Actually, now that I think about it, yeah, it should be 1.6, maybe even more than 1.6. Okay. Anyhow, this tells us that 2 to the 1.6x should equal 3 to the x, approximately. Okay? What'd you get?
1.58.
Yeah, 1.58. Okay.
I was close with that 3 over 2, huh?
I'm sorry?
I was close with that 3 over 2, huh?
No. No. 3 over 2 is 1.5. This is 1.6. Yeah, it was close, but that was just,
This is
don't
a lot.
expect it to be close if the numbers are a little different. Okay? Okay. What's this mean? It means the graph of y equals 3 to the x is the graph of y equals 2 to the x horizontally compressed by factor 1.6. Now, horizontal compression is new to you, but that's it. That just follows from everything I said before, which means that if I do my graph of 2 to the x, not very well done, but there it is. What has to happen to this point?
Has to move 1.6 times closer.
1.6 times closer. How do you do 1.6 times closer? Well, 1.6 times closer, well, let's see, what we did before, we moved 3 times closer, right? Well, moving 3 times closer is just like moving 1/3 as far, right? So we take our distance and go 1/3 of that distance, right? Well, this time we have to do 1 over 1.6 times the distance, right? So moving 1.6 times closer means moving 1 over 1.6 times as far. Now 1 over 1.6 is about 0.6. Okay? So that's 0.6 times as far. Since 1 over 1.6 is approximately equal to 0.6, it's 0.625, okay? It even gone down to 1.58 something. I still don't think it's going to go over 0.65, so I think it's going to round to 0.6. All we're wanting to do is get an approximation to this graph, right? Okay? So that means what? Well, I'm going to move this point 0.6 times as far. Now let's just draw a line from here to here. Half as far would be here, right? Down about in the middle. And 0.6 times as far would probably put it here. Now for this one, well, we draw a little segment from here to here. Halfway is here. So 0.6 times would be maybe about here. This point isn't going to move. This point is going to move closer. Here's halfway, so it's going to move to about here. This point, halfway is obviously here. 0.6 here would be like this. Now I could actually figure out what the coordinates would be based on the 0.6, but I just want to do it visually. Because in the first place, 0.6 isn't all that accurate. Okay, it's probably closer to 0.64 or something like that. Okay, 6364. Actually closer, probably 64. Anyhow, I can now draw a curve through these points. Okay? And that would be an approximate curve for y equals 2 to the 1.6x, which equals 2 to the 1.6 to the x, which is approximately equal to 3 to the x. Now I could graph 3 to the x, couldn't I? You know, 3 to the x would go through the same 0, 1 point. It would go through 1, 3. So here's 1 and here's 3. To go up from 1 over from 3 puts us about here. That's pretty darn close to the green curve, isn't it? And when x is 1, we should get 1/3. Well, 1/3, we cut this down here, cut it down here, come over above 1, and yeah, we're pretty much right on the curve there. Okay? So just with those 3 points, you know, we're going to, of course, have the point 2,9, which is going to be up about here, and the graph doesn't go that high, but at least for these 3 points, it looks like this red curve is pretty close to the green curve, right? And I didn't angle it up quite steep enough because it's going to get pretty steep to get all the way up to here. It's going to stay pretty close to that green curve. Okay? So here's a graph of y equals 3 to the x with a question mark. You know, how good is that? How good is that? That's a hand-sketched graph, right? Now those of you who are very meticulous would come out with graphs that are pretty close. If you slop down graphs the way I do, they won't be as close, but they should still be convincing that this really works. Now let's just look at the algebra of it.